Welcome to class. Today we're going to talk about finding relatives, and we're going to focus on a genetic genealogy technique called family-based phasing. The objective of today's lesson is for you to be able to identify what we're calling identical by descent segments using family-based phasing. I became interested in genetic genealogy because, being a person of African descent, most of my ancestors came from Africa by way of the transatlantic slave trade. And the only way to find family groups in Africa is to use a DNA test connected to large customer databases. And so people of African descent are using the kits for this purpose. Just a little reminder, just a refresher from biology. What we're talking about are autosomal chromosomes, and that is the 22 pairs of chromosomes that we inherit from our parents, not counting the sex chromosomes. And if you recall, in each pair of chromosomes, we inherit one from the biological mother and the other one from the biological father. So let's talk about we're going to use that and talk about identical by descent. So in this example, the U here represents a DNA segment that was read by the commercial company. You see the column on the left here, the ATG, is the same as from the mom, meaning that this was inherited from the mom's side. And this TAC column on the right is the same as from the dad, meaning that this was inherited from the dad. So this is a genetic inheritance. What the machine does as it reads the DNA from the commercial companies is actually it will zigzag along the genome, reading at particular points without really taking into consideration of which pair is being read first. And so sometimes the pair from the variant from the mom is read first, and sometimes the variant from the dad is read first. And so even though here, when the segment is being compared to an unknown person, represented by match with a question mark, an unknown person, even though this looks like a true match, it's not actually a real match, and we'll call it identical by state, meaning that basically it looks identical, but is identical by some other reason other than by actual descent. Okay, so let's compare this to this next example here. Here, your segment recorded as ATG is matched or compared to this unknown person in this column ATG. And then when we look at what was inherited from the parents, we see that it matches at least one parent, the mom, here in this column ATG, and so on. So we see that this segment that's being compared has indeed been inherited from at least one parent. And so this provides evidence that you are related to this unknown person, assuming that unknown person also match one of their parents at the same segment. And this whole process of finding identical by descent segments where it actually will match one of the parents, this is what we're calling family-based phasing, where the readings, are actually compared to the parents to determine the identical by descent segments. All right, let's look at a new example. In this one, I want you to think about this situation and determine if it is an identical by descent segment. Here's the unknown person. It looks like they match the segment here in the column started with TAC, and here's your segment, and you would compare it to one of the parents. Is this identical by descent? All right, if you said yes, this is identical by descent, that is correct. And this is family-based phasing, assuming that the unknown match also match one of their parents. Okay, let's do a bit of recall. I'll give you a few moments to answer this question. When you're using direct-to-consumer ancestry, autosomal DNA tests, and there is a match, family-based phasing is a genetic genealogy technique that should be used to provide evidence of relatedness. Okay, in today's lesson, you learn about identical by descent using the genetic genealogy technique called family-based phasing. And I end with this picture here to remind you of the power that is using the commercial DNA testing to bring together families. So this is a blended family where the two of the members are Ghanaians and the other two are African Americans. And in this picture, families that were separated by the transatlantic slave trade have reunited using the commercial DNA test.